Hello everyone, welcome to Infinity Learn. My name is Vibhati and I'm your physics educator on Infinity Learn. So let's start with AIIMS paper weekend test physics portion. So this is your question number one. Consider the following statements. The coefficient of friction between two surfaces will increase if the surfaces are made rough. Yes, the friction depends on the nature of the surfaces, the roughness of the surfaces, right? If surface is rough, then friction will be more, right? So yes, mu will increase with the increase in the roughness of the surface. So this statement is true. Rolling friction is more than sliding friction? No, rolling friction is less than sliding friction, right? So correct answer is option 4. B is false and A is true. Next question is question number 2. A stone weighing 1 kilogram and sliding on ice with velocity 2 meter per second is stopped by friction in 10 seconds. The force of friction will be mass of the stone is 1 kilogram and its initial velocity is 2 meter per second and final velocity will be 0 because it is stopped in 10 seconds, right? So force of friction will act as a retarding force in this particular situation. So retardation provided by the friction is, let's say, A. So we can apply V is equals to U plus AT in this situation to find the value of A. Why? Because friction is given constant. For constant acceleration and retardation, we can apply equation of motion, right? So V is equals to 0, U is 2 plus AT is 10. So A will be minus 0.2 meter per second square, right? So force of friction will be M into A, that is 1 into minus 0.2, that is equals to minus 0.2 Newton, and correct answer is option 2. Next is question number 3. If the normal force is double, the coefficient of friction is. If the normal force is doubled, then coefficient of friction will not change because it is the property of the material, right? So correct answer is option 1. Two wires of the same material have lengths in the ratio 1 is to 2, L1 upon L2 is 1 by 2, and radii R1 upon R2 in the ratio 1 upon root 2. If they are stretched by applying equal forces, that means F1 upon F2 is 1 upon 1, the increase in their lengths will be in the ratio. It is given that the wire are of the same material. That means Young's modulus are also equal for both of these wires, right? So if y1 is equals to y2, then you can write for wire 1 f1 L1 upon A1 delta L1 is equals to f2 L2 upon A2 delta L2, right? We need to find the increase in length ratio. So basically we want to find delta L1 upon delta L2. So it will be F1 L1 upon F2 L2 is equals to A1 delta L1 upon A2 delta L2. F1 upon F2 is 1, L1 upon L2 is 1 by 2 into 1. A1 upon A2 will be pi R1 square upon pi R2 square. So A1 upon A2 will be the ratio of R1 upon R2 whole square, that is 1 by root 2 whole square, that is 1 by 2, and it is delta L1 upon delta L2, right? So delta L1 upon delta L2 is 1 is to 1, which is option 3. Next is question number 5. An elastic material with Young's modulus Y is subjected to a tensile stress S. Elastic energy stored per unit volume of the material is. So elastic energy stored per unit volume of the material is given by stress square divided by 2 times Young's modulus. This question is formula based, right? So elastic energy stored per unit volume will be S square upon 2y, which is option 3. Next is question number 6. Two wires of same diameter of the same material have the length L and 2L. So diameter is same, that means radius is same. Oh, and radius is same, that means area of cross section will be same. So A1 upon A2 will be 1 upon 1. Material is same, that means Y1 upon Y2 is 1 is to 1, or you can say that Y1 is equals to Y2. Wire 1 has length L and wire 2 has length 2L. If the force F is applied on each wire, then the ratio of work done in the two wires will be. Ratio of work done, we need to find the ratio of work done. So work done is given by half Fn, right? So W1 will be half F1 L1 and W2 is half F2 L2. If you take the ratio, it will be W1 upon W2 is equals to F1 L1 upon F2 L2. F1 is equal to F2 because we are applying the same force. Then W1 will be W1 upon W2 will be the ratio of L1 upon L2, and that is equals to L upon 2L, which is 1 by 2. So the ratio of work done will be 1:2, which is option 1. Next is question number 7. In the given figure, if the dimensions of the wire are same and materials are different, Young's modulus is more what? So this is load versus extension graph, and dimensions of the wires are same. That means length and area of cross section of the wires is given same, right? We need to find the uh, comparison of Young modulus of wires A and B, right? Y is equals to Fl upon A delta L, right? L and A are same for both the wires. So you can see that Young's modulus is directly proportional to F upon delta L, where delta L is what? Extension in the wire, right? Now for the same extension, if you keep extension on in both the wires same, then Young's modulus will be directly proportional to load F if delta L is kept same, right? So if delta L is kept same, load in A is greater than load in B, right? And if F is directly proportional to Y, then Y of A will be greater than Y of B. So Young's modulus will be more for Y of A as compared to B. So correct answer is option 1. Next is question number 8. For steel, Y is equals to 2 into 10 power 11 Newton per meter square, and the force required to double the length of the steel wire of area 1 centimeter square is. So area of cross section is given as 1 centimeter square, which is equals to 10 power minus 4 meter square, right? Let's say initial length of the wire is L and final length of the wire is 2L. So delta L, that is L2 minus L1 will be 2L minus L, that is equals to L. What is the strain in the wire? Strain is delta L upon initial length, that is equal to L. So it will be L upon L is equals to 1. So basically Young's modulus is stress, that is force upon area, divided by strain, that is equals to 1 in this particular question, right? So force will be Young's modulus into area. Young's modulus is 2 into 10 power 11 into area is 10 power minus 4. So it will be 2 into 10 power 7 Newton. So this is the force required to double the length of the wire, which is option 1. Next is question number 9. A cable that can support a load W is cut into two equal parts. The maximum load that can be supported by either part is. So breaking stress is given by force upon area. If you are keeping the load same and you are not changing the area of cross section of the wire, then the breaking stress will not change, right? So you can say that the breaking stress depends on the load as well as area of cross section. It does not depend on the value of the length of the wire, right? So if you change the wire, the value of maximum load will not change. So correct answer is option 3, which is W. Question number 10. The temperature of the wire is doubled. The Young's modulus of elasticity. So delta L, that is the extension in the wire, will be because of the increase in temperature, right? Thermal expansion. Delta L is given by L alpha delta T. If you are increasing the temperature, then the length of the wire will increase, right? Now, Y is F L upon A delta L. Delta L is what? L alpha delta T. So, basically Y will be F upon A alpha delta T. Now, you can see that the denominator value is increased, right? And because of that, overall value of Young's modulus will decrease. So, correct answer is option 4. Next is question number 11. When a pressure of 100 atm is applied on a spherical ball, its volume reduces to 0.01%. That means delta minus delta V upon V will be 0.01 divided by 100. Why minus? Because the volume is reducing, right? Okay. The bulk modulus of the material of the rubber in dyne per centimeter square is, so bulk modulus is what? PV minus PV upon delta V. So it will be minus P is 100 ATM divided by delta V, that is minus 0.01 divided by 100, and it will be 10 power 6 ATM. Right, but we need to find the answer in dyne per centimeter square. For that, what we'll do, we'll convert this ATM into Newton per meter square, and after that I'll convert Newton per meter square to dyne per centimeter square, right? So we know that 1 ATM is equals to 10 power, approximately 10 power 5 Newton per meter square, or 10 power 5 Pascal. So bulk modulus will be 10 power 6 into 10 power 5 Newton per meter square, that is 10 power 11 Newton per meter square, right? Now 1 Newton is 10 power 5 times, and 1 meter square is 10 power 4 centimeter square, right? So 10 power 11 into Newton is 10 power 5 dyne divided by centimeter square, that is 10 power 4 centimeter square. So it will become 10 power 12 dyne per centimeter square, right? So bulk modulus will be option 3, 1 into 10 power 12 dyne per centimeter square. Next is question number 12. Two wires of copper having the length in the ratio 4:1 and the radii ratio as 1:4 are stretched by the same force. The ratio of longitudinal strain in the two will be. So we have wires of copper, that means Young's modulus for both the wires is same. L1 upon L2 is given as 4 upon 1, and R1 upon R2 is given as 1:4. So R1 square upon R2 square will be 1 upon 4 square, that is 16. And if you multiply this term by pi in numerator and denominator, it is nothing but the area of cross section of these two wires, pi R1 square upon pi R2 square, that is A1 upon A2, and it is equals to 1 by 16. Now these two wires are stretched by the same force. So F1 upon F2 will be 1 upon 1, right? Now let's use this information to find the value of ratio of longitudinal strain. Okay. So if y1 upon y2 is same, y1 is stress in 1 divided by strain in 1 is equals to y2, that is stress in 2 divided by strain in 2. Okay, stress is force upon area, so this is F1 upon A1 upon strain in 1 is equals to stress, that is F2 upon sorry A2 divided by strain in 2. Okay, so it will be F1 upon A1 into A2 upon F2 is equals to strain in 1 divided by strain into F1 upon F2 is 1:1. So A2 by A1 will be 16 by 1, that is strain in 1 divided by strain in 2. So correct answer is option 2, that is 16:1. Next question is question number 13. A steel wire of cross section area 3 into 10 power minus 6 meter square can withstand a maximum strain 10 power minus 3. Young's modulus of steel is 2 into 10 power 11 Newton per meter square. The maximum mass this wire can hold is. So basically Young's modulus is what? Force upon area into delta L upon L. So Fl upon E delta L is Young's modulus. Now maximum mass it can hold, that means the maximum load, right, that is equals to mg into L upon A delta L, right? So M will be Y A delta L upon M G into L, right? We are finding the value of M, so it will be G into L. Y is 2 into 10 power 11, A is 3 into 10 power minus 6, G is 10 and delta L upon L, that is strain, is 10 power minus 3. Right, so after solving this value, we will get the value of mass as 60 kilogram, which is option 2. Next is question number 14. The load versus elongation graph for 4 wires of the same material and same length is shown in the figure. The thickest wire is represented by the line. So we have load versus elongation graph, and we need to find the thickest wire, right? Material is same and length is given as same. So y is equals to F L upon A delta L. Material is same, that means Young's modulus is same for all the wires and length is same. So basically A delta L is directly proportional to F, where F is load and delta L is elongation, right? So for the same value of elongation, you can see that the load value in D is more than load value in C, it is more than B, and it is more than A, right? So if delta L is kept constant, that means A is directly proportional to load, right? Load is more in D for delta L constant. So area of cross section of D should be more as compared to C than B than A, right? And if more is the area of cross section, thickness of the wire will be more, right? So thickest wire is OD, which is option 1. Next question is question number 15. Which of the following statement is or are correct? Incompressible liquids have finite value of bulk modulus of elasticity, right? So bulk modulus is uh, minus P upon delta V by P. But if the liquid is incompressible, you cannot change the volume of the liquid. So delta V is 0. So basically this is minus P upon 0 upon V. So it is 1 upon 0, which is infinite, right? So for incompressible liquids, the value of bulk modulus is infinite, not finite. So this statement is false. Compressibility is inverse of bulk modulus, which is true, right? So statement 2 is correct. So correct answer is option 2. Only 2 is correct. Next is, two wires are made of the same material and have the same volume. The first wire has cross-sectional area A and second wire has cross-sectional area 3A. So if material is same, Young's modulus is same and the volume is same. V1 is equals to V2 for both the wires. Volume is also given by area into length, cross-section area into length. So it is A1 L1 is equals to A2 L2, right? First wire has cross-section area A and second wire has cross-section area 3A, right? So basically L1 upon L2 is 3, right? And A1 upon A2 is A upon 3A, that is equals to 1 by 3, right? Now if Young's modulus is same and we want to find the force applied on the second wire so that we get the same extension as that of the one, then let's use this equation. If y1 is equals to y2, so y1 is f1 L1 upon A1 delta L1 is equals to F2 L2 upon A2 delta L2, right? F1 is F, L1 upon L2, right? And delta L1, delta L2 are equal, right? So it will be F2 into A1 upon A2, right? L1 upon L2 is 3. So F2 will be F into 3 into A2 by A1, that is equals to 3. So 9F is the force that must be applied on second wire to get the same amount of extension as that of the first wire. So correct answer is option 3. Next is, if the compressibility of a material is 4 into 10 power minus 5 per atm, if pressure is 100 atm, the volume is 100 centimeter cube, then find the value of delta V. right? So compressive bulk modulus is what? P V upon delta V. So delta V will be PV into 1 by V, right? P is 100, V is 100 centimeter cube into 1 by V. That is compressibility, that is equals to 4 into 10 power minus 5. So delta V, that is the change in volume, will be 0.4 centimeter cube, which is option 1. Next is, the following four wires are made of the same material. Which of this will have the largest extension when the same tension is applied? Right. So, basically Y is F L upon A delta L. Right. And wire are made of the same material. That means Young's modulus is same for all the wires. And tension, that means load applied, is also same. Right. So, Y is same, F is same. So delta L is directly proportional to L upon A, right? Delta L is directly proportional to L upon A. The ratio L upon A is larger, then the delta L value will be larger. And you can calculate this ratio for all these three wires to get the correct answer, which is option 1, right? Length upon area of cross section ratio will be larger for wire 1, so that is why option 1 is correct. Next is, theoretically, the value of Poisson ratio sigma lies between. So this is again information based question, and theoretically the value of Poisson's ratios lies between -1 to 0.5. So correct answer is option 2. Question number 20. If the Poisson's ratio of a material is -1 by 2, then the material is elastic, incompressible, compressible, and none of the above. We know that compressibility is 1 upon bulk modulus, right? But delta V upon V is also given by 1 plus 2 sigma delta L upon L, right? But sigma is -1 by 2. So delta V upon V will be 1 plus 2 times -1 by 2 into delta L upon L, which is 1 minus 1. So it is 0. So delta V upon V is 0, right? So, bulk modulus is given by P upon delta V upon V. Delta V upon V is 0. So, it is P upon 0, that is equals to infinite. And bulk modulus is infinite for incompressible materials, right? So, correct answer is option 2. Next is frictional forces, conservative, non-conservative, always 0, always constant in magnitude. So friction force is non-conservative force. Why? Because work done by friction force depends on the path taken by the particle, and in a complete round trip, the work done of friction force is not zero, right? So there are some, losses during the friction force, right? That is why it is non-conservative in nature. So correct answer is option 2. Next is, a body is projected along a rough horizontal surface with velocity 6 meter per second. If the body comes to rest after traveling a distance of 9 meter, the coefficient of sliding friction is. So this body is coming to rest, right? That means final velocity is 0. So this body is experiencing retardation, right? So let's find the value of retardation first. We can apply this equation. V square is equals to u square plus 2as. So this is 0 square is equals to u square, that is 6 square plus 2a. S is 9, right? So 0 is equals to 36 plus 18a. So a will be minus 2 meter per second square. This is the value of retardation. Fine. Now, if the body is moving in this direction with some velocity, then friction force in this direction, right? Mg will be downwards and normal reaction R will be upwards. So R is equals to Mg and friction force is nothing but mu into R, right? So basically mu Mg is the friction force, right? So retardation produced by this friction force will be mu G. So you can see that minus mu G is equals to minus 2. So mu will be 2 upon G, that is equals to 2 upon 10 and it is 0.2. So coefficient of sliding friction is 0.2, which is option 4. Next is, Granules are dropped on a conveyor belt at the rate of 0.5 kilogram per second. dm by dt is 0.5 kilogram per second. The extra force required in newtons to keep the belt moving at 2 meter per second is. So force is V dm by dt, right? If velocity is constant, but mass is the rate of change of mass is given, right? So V is 2 into 0.5 is dm by dt, so it is 1 Newton, right? So extra force required in newtons to keep the belt moving at constant velocity is 1 Newton, which is option 1. Next is a body of mass 60 kilogram is pushed with just enough force to start it moving on a rough horizontal surface with mu s is equals to 0.5 and mu k is equals to 0.4, and the force continues to act afterwards. The acceleration of the body is. So basically, the enough force is nothing but the force equal to limiting friction. Why? Because when limiting friction is there, when the applied force is equals to limiting friction, then body is on the verge of moving, right? So limiting friction in this case, mg is in downward direction, normal reaction are upwards, and friction will be in backward direction. So limiting friction will be mu s into r, and that is equals to mu s into mg, right? So mu s is 0.5, m is 60, and g is 9.8. So this is the value of friction. So we are applying the same amount of force on this body so that it just starts moving, right? So after the motion of the body starts, it experiences kinetic friction, right? So kinetic friction will be mu k into mg. Kinetic friction Fk will be mu k into mg. Mu k is 0.4, m is 60 into g is 9.8, right? So basically in this situation, body is experiencing forward force of 0.5 into 60 into 9.8 Newton, and at the same time kinetic friction of 0.4 into 60 into 9.8 Newton. And let's say acceleration of the body is in this direction. So net force in the direction of acceleration of the body is given by 0.5 into 60 into 9.8 minus 0.4 into 60 into 9.8. So it will be 60 into 9.8 into 0.5 minus 0.4, 0.1. Now net force divided by mass will give you acceleration. So this will divide this, right? So acceleration will be 9.8 into 0.1, which is 0.98 meter per second square, and that is option 1. Question number 25. The block of mass 10 kg is on a rough horizontal table. The coefficient of friction between the block and the table is 0.45. Then the friction force on the block is given by. So basically, friction comes into action when there is some sliding tendency, and or you can say that when the block is trying to start the relative motion, right? But you are not applying any force. You are not forcing this block to start any relative motion. External force is not present, so right? Okay, so friction will not be there. Why? Because how can friction oppose anything if anything is not there, right? Okay, so correct answer is C. Friction will act only if there is some tendency of relative motion, right? There is no tendency developing in this block of relative motion. That is why friction will not be there. So correct answer is option 4. Next is question number 26. A suitcase is gently dropped on a conveyor belt moving at 6 meters per second. If the coefficient of friction between the belt and the suitcase is 0.5, find the displacement of suitcase relative to conveyor belt before the slipping between the two is stopped. Right? So, when slipping will stop, the relative velocity will be 0. So, retardation faced by the block will be mu mg, right? So retarding force will be friction, that is equal to mu mg. So retardation will be mu g, or minus mu g is the acceleration, right? So it is minus 0.5 and g is 10. So it will be minus 5 meter per second square. Now what we can do is we can apply this equation to find the value of s, right? 0 is equals to u square, that is 6 square, plus 2a is minus 5 into s is not known. So this is 0 is equals to 36 minus 10s. So s will be 3.6 meter, which is option 1. Next is question number 27. The following graph is drawn between the frictional force between a body and the surface and the external force acting on the body. AM and DN represent. So this is AM. This is the maximum value of static friction, right? This is the maximum value of static friction. So this is nothing but the limiting value of static friction, right? Dn is in the region of kinetic friction, where friction becomes constant and object is in motion, right? Relative motion. So Dn represents the value of kinetic friction. So correct answer is option 1, limiting and kinetic frictions. Question number 28. The limiting friction between two surfaces depends on the nature of two surfaces. Yes, it depends on the roughness and nature of the two surfaces. Friction is directly proportional to normal reaction. Yes, and it is independent of apparent area of contact. Yes, friction is independent of apparent area of contact. So all of these three statements are correct. So correct answer is option 4, A, B and C. Question number 29. The angle made by the resultant of normal reaction and limiting value of frictional force with normal to the surface is called. So this is your block, and let's say this is normal reaction, this is the friction, then this is the resultant of this normal reaction and friction. So angle made by the total contact force and normal reaction is known as angle of friction, that is option 2. Next is question number 30. If mu s, mu k and mu r are the coefficients of static, kinetic and rolling friction respectively for a body on a given surface, then we know that static is more than kinetic is more than rolling, right? So that is why mu s is greater than mu k is greater than mu r. So correct answer is option 3. Question number 31. Friction force can be zero even though the contacting surfaces is rough. Yes. If there is no sliding tendency of the body, then friction force can be zero. Even though there is no relative motion between surfaces, friction force may exist between them. Yes, and like two block system, if these two blocks are moving together, right, then friction force may exist between these two surfaces. So this statement is also true. So correct answer is option 1. Both A and B are true. Question number 32. A rectangular block of size 10 cm, 8 cm, 5 cm is kept in three different positions P, Q, R in turn as shown in the figure. In each case, the shaded area is rigidly fixed and a definite force F is applied tangentially to the opposite face to deform the block. The displacement of the upper face will be. So eta is F upon A in divided by theta, right? So F upon A theta is equal to eta. Now the block is same in all the three cases. So eta will be same, right? And we are applying a definite force F, right? So if I talk about the deformation, theta will be F upon A into eta, right? So F and eta are constant, so you can see that theta is inversely proportional to A, right? If area of cross section is more, area over here, this shaded area is more, theta will be less. And if shaded area is less, theta will be more. So deformation or displacement of the upper face will be more in the less area, which is option, which is diagram Q, right? So it will be maximum in Q position. Question number 33. Aeroplanes are streamlined to reduce. So aeroplanes are streamlined to reduce the fluid friction. Fluid friction is the friction acts on the body when bodies move in a liquid or a gas, right? So correct answer is option 1. Question number 34. A rocket of mass 1000 kilogram, 1000 kilogram is to be projected vertically upwards. The gases are exhausted vertically downwards with velocity 100 meter per second with respect to the rocket. what is the minimum rate of burning of fuel so as to just lift the rocket upwards against the gravitational attraction. So basically, the fuel force should balance mg, right? So it will be dm by dt into v, and it should balance mg, right? So v will be uh, dm by dt into v will be 1000 into 10, right? So v is 100 meter per second. So you can write dm by dt is equals to 1000 into 10 divided by 100, and that is equals to 100 kilogram per second, which is option 2. Next is, to avoid slipping while walking on ice, one should take smaller steps because of the friction on ice is large normal reaction. Friction on ice is small and smaller normal reaction. Okay, uh, we should take smaller steps because friction on ice is small and smaller steps will ensure large normal reaction. Fine. So that is why correct answer is option 3. Friction of ice is small. Next question is question number 36. The increase in length on stretching the wire is 0.05%. If its Poisson's ratio is 0.04, then its diameter. So basically, Poisson's ratio is given by lateral strain divided by longitudinal strain, right? So longitudinal strain, uh, zero point 0.4 is equals to what? Lateral strain divided by longitudinal strain. Okay, so lateral strain will be zero point 0.4 into longitudinal strain, that is equals to 0.05 divided by 100, right? So lateral will be your 0.02%. So the change in diameter will be your 0.02%. So it will reduce by 0.02% because you are stretching the wire. So diameter will reduce. So correct answer is option 1. Next is question number 37. Coefficient of friction between the block and the floor is mu. F that will move the block on the floor with a uniform speed is. So basically the object should move with constant speed, right? That means net force along x-axis as well as y-axis should be 0. So let's make FBD. This component will be F cos theta. This component will be F sin theta. This is mg. Normal reaction will be upwards and friction will be in the backward direction. So basically, R will balance F cos theta plus mg, and friction force will balance F sin theta, right? But friction force is mu into R, so it will be mu F cos theta plus mg, and this is equals to F sin theta, right? So you can write mu F cos theta plus mu mg is equals to F sin theta, right? So mu mg will be F sin theta minus mu F cos theta, right? You can take F common, so it will be F is equals to mu mg divided by sin theta minus mu cos theta, right? So correct answer is option 4. Next is question number 38. A 5-meter long wire is fixed to the ceiling. The weight of 10 kg is hanged at the lower end and is 1 meter above the floor. The wire has elongation by 1 millimeter. The energy stored in the wire due to stretching is, so energy stored is half F into L. F will be mg and L is 1 millimeter, right? So it will be half mg into 1 millimeter, that is 10 power minus 3. So it will be 0.05 joule. This is the energy stored in the wire due to stretching, which is option 2. Next is question number 39. A block of mass 5 kg is resting on a horizontal surface, is connected by a cord passing over a light frictionless pulley to a hanging block of 5 kg. The coefficient of kinetic friction between the block and the surface is 0.5. We need to find the tension in the cord. So basically this 5G will be in downward direction, tension will be in upward, and let's say it is moving in this direction with acceleration A. This 5 kg will experience tension in this direction, friction backward, then acceleration A, right? So for this 5 kilogram, you can write the equation phi g minus tension is equals to phi A, and for this 5 kilogram, you can write phi T minus F is equals to phi A. Now you can equate this term with this term because both are equal to phi. So phi g minus tension is equals to tension minus friction. So 2T is equals to phi g plus friction. Friction is mu mg, so it is phi g plus 0.5 into phi g, and that is 2T. So tension will be, you can take phi g common, so it is 1 plus 0.5, 1.5 divided by 2. You can put the value of G as 9.8 meter per second square, and after that you'll get the answer as option 3, that is 36.75 Newton. Next is question number 40. The temperature of a wire of length 1 meter and area of cross section as 1 centimeter square, that is 10 power minus 4 meters square, is increased from 0 to 100 degrees Celsius. If the rod is not allowed to increase in length, the force required will be. So we can apply this equation. F is equals to F, y is equals to F L upon A delta L. But if you look at the thermal expansion formula, delta L will be L alpha delta T. So F L upon A L alpha delta T. This L will cancel this L. So we have Y is equals to F upon A alpha delta T. Right? So F will be Y A alpha delta T. Y is 10 power 11, area of cross section is 10 power minus 4, alpha is 10 power minus 5, and change in temperature is 100, right? So it will be 10 power 4 Newton. So force required is 10 power 4 Newton, which is option 2. Next is question number 41. A stress of 10 power 6 Newton meters per meter square is required for breaking the material. If the density of the material is 3 into 10 power 3 kilogram per meter cube, then what should be the length of the wire made of this material so that it breaks under its own weight, right? So stress is equals to force upon area. Area into length is equals to volume. Density is mass upon volume, which is equals to mass upon area of cross section into length, right? So area will be mass upon density into length. So stress will be force upon mass upon density into length, and that is equals to 10 power 6. Okay. So length will be 10 power 6 into m divided by force into density. So it will be 10 power 6 into m, force will be mg, load will be mg, m into g is 10 into rho is 3 into 10 power 3, right? So it will be 10 power 2 divided by 3, and that is equals to 33.3 meter, which is option 3. Next is a thick rope of rubber of length 8 meter and density 1.5 into 10 power 3 kilogram per meter cube has Young's modulus 5 into 10 power 6 Newton per meter square. When hung from ceiling of a room, the increase in length due to its own weight will be, right? So again we'll apply y is equals to F A F L upon A delta L, right? And we can apply this previous concept over here because density is given, right? So basically stress will be F uh, F rho L upon M, right? So stress will be F rho L upon M divided by strain, that is delta L upon L, right? And that is equals to Young's modulus. F rho L upon M is the stress divided by strain, and that is equals to Young's modulus, right? F is given as mg, right? Because load is mg, rho is given, L is given, so this will be L square upon M delta L, and that is equals to Y. So M will cancel this M. So we have delta L is equals to rho G L square divided by Y. You can put all these values in this expression to get the value of delta L, and that will be 9.6 centimeter. Next question is question number 43. An elevator cable is to have a maximum stress of 7 into 10 power 7 Newton per meter square to allow for approximate appropriate safety factors. Its maximum upward acceleration is 1.5 meter per second square. If the cable has to support the total weight of 2000 kilogram of a loaded elevator, the area of cross section of the cable should be. So this is your cable and it is supporting a load of 2000 kilogram, right? So its mass will be 2000, and because of that it will experience a force of 2000 G in the downward direction, tension in the upward direction, and acceleration is in upward direction. So you can write T minus 2000 G is equals to 2000 into A. Net force is equals to mass into acceleration. So T will be 20,000 plus 3000, that is equals to 23,000 Newton, right? Now stress is force upon area. So force is tension. So 23,000 divided by area is equals to 7 into 10 power 7, and area of cross section will be 23,000 divided by 7 into 10 power 7. After solving this value, you'll get the area as 3.23 centimeters square. Next is question number 44. The length of a metal wire is L1 when the tension in it is T1. Its length is L2 when the tension is T2. The natural length of the wire is. So let's say natural length of the wire is L, right? So when tension is T1, extension in wire is L1 minus L, and when tension is T2, extension in wire is L2 minus L. Now we are using the same metal. That means Young's modulus is same for both the wires, right? Young's modulus is given by FA divided by F upon A divided by delta L upon L. So it will be FL upon A delta L, right? So for the first case, you can write Young's modulus as T1 into L divided by area of cross section A into delta L, that is L1 minus L. And for the second case, you can write Young's modulus, which is same as that of the first one, T2 into L divided by area into L2 minus L, right? So this will cancel this will cancel this. You can cross multiply, so it will be T1 L2 minus T1 L is equals to T2L minus T2L, right? So it will be T2 minus T1L is equals to T2L1 minus T1L2, right? And L will be T2L1 minus T1L2 divided by T2 minus T1. I hope this is clear, right? So correct answer is option 3. Next is question number 45. A man is running on ground. The coefficient of friction between the ground and the man is 0.25. Assume that the center of mass of man moves horizontally, then which of the following statement is incorrect? Normal reaction between man and the ground is equal to weight of the man? Yes, because mg will be in this direction and normal reaction will be in this direction. Direction of friction on man is in the direction of motion of man. Okay. Okay. Next is direction of friction on man is opposite to the direction of motion of man. Fine. Next is maximum acceleration of man can be g by 4. Right? Why? Because every action has equal and opposite reaction. So if a man is running on this one ground, it will push the ground in backward direction and ground will push it in the forward direction. Right? So it will experience a maximum force of mu mg in the forward direction, and acceleration will be mu g, that is equal to 0.25 into g, that is g by 4. Now man is providing the friction in the backward direction, so its reaction on the man will be in the forward direction. So direction of friction on the man is in the direction of motion of the man, not in the opposite direction of motion of the man. So statement 3 is incorrect, right? Excellent. Next is question number 46. A block of mass 10 kg is pushed by a force F on a horizontal rough plane, moves with acceleration 5 meter
per second square. When the force is double, the acceleration becomes 18 meter per second square. What is the coefficient of friction? So this is the block. Mg will be downward, reaction will be upwards, and its friction will be in backward direction if it is moving in the forward direction, and this is the direction of applied force, right? Okay, so F minus friction, that is mu mg, is equals to m into A in the first case, right? M is 10, A is 5, so it will be 50, right? F minus mu into m, that is 10, into G is 10, so it is mu 100 is equals to 50. Fine, so F will be 50 plus 100 mu, right? In the second case, when the force is doubled, acceleration becomes 18, right? So next equation will be 2f minus mu mg is equals to 18 into 10, that is 180. Let's put the value of f in this equation. So this will be 2 times 50 plus 100 mu minus 100 mu is equals to 180. Okay, so it will be 100 plus 200 mu minus 100 mu. 100 mu is equals to 180. So 100 mu will be 80 and mu will be 0.8. So this is the coefficient of friction, that is option 1. Next is question number 47. Number of coins each of mass 400 gram are placed one over the other. The minimum horizontal force required to pull the 8th coin from the top without disturbing the remaining is 10 Newton. G is 10 meter per second square. The coefficient of friction between any two coins is. So basically, this is the pile of 7 coins and this is the 8th coin, right? And we have some coins below this 8th coin, right? So, because of the mass of the 7 coins, it will have 7 mg downwards, normal reaction upwards, right? So, if you try to pull this coin in this direction, it will experience friction forces because of this surface as well as this surface. So, friction force because of this surface is, let's say, F1, and because of this surface is F2, right? And applied force is 10 Newton, right? So, this is the minimum force. That means this 10 Newton should balance F1 plus F2, right? F1 is the friction force on the upper surface, right? So this is provided by the 7 mg pipe, 7m pipe, right? So friction force F1 will be mu into 7 mg, right? And that is equals to 7 mu mg, right? On the lower face, you can see that it will be nothing but the interaction of the lower surface of the coin and the rest of the pie, like this, right? So over here, we'll have to include all the 8 coins. So 8 mg will be in downward direction, normal reaction R2 will be in upward direction, and friction F2 on the surface will be like this. So F2 will be mu into 8 mg, right? So total 10 Newton is balanced by F1 plus F2, that is 7 mu mg plus 8 mu mg, that is 15 mu mg, right? Okay. So you can write 10 is equals to 15 mu, m is 400 grams, so it will be this into G is 10, right? So this 3 will cancel this 3 and we have 2, 3 and this will be 2, right? So mu will be 1 by 6. So this is the coefficient of friction between any two coins, that is option 3, 1 by 6. Next is question number 48. A rocket of initial mass 6000 kilogram ejects mass at constant rate of 200 kilogram per second, which is equal to dm by dt. With constant relative speed of 800 meter per second, the acceleration of the rocket after 5 seconds is, right? So basically, this rocket is ejecting mass at the rate of 200 kilogram per second. So per second, the mass of the rocket is decreasing by 200 kilogram. So after 5 seconds, the decrease in mass will be 200 into 5, that is 1000 kilogram. So remaining mass will be 6000 minus 1000, that is equals to 5000 kilogram, right? Okay, so this is the remaining mass, and for remaining mass you can apply F is equals to ma. So S will be 5000 into A is equals to F, that is dm by dt into V, that is 800 into 200. So A will be, this three zeros will cancel this three zeros. So we have 160 divided by 5, and that is equals to 32 meter per second square. Option 4 is correct. Question number 49. A block of mass 2 kg is kept on a rough horizontal surface. It is pulled by horizontal force F. Mu s is given, mu k is given. Let's find the value of limiting friction first. 2g will be downward direction. Normal reaction will be in the upward direction. Let's say this is the force direction, then friction will be in this direction. Limiting friction will be mu s into mg, and that is equals to zero point 0.6 into m2 into 9.8, that is equals to 11.76 Newton, right? 11.76 Newton. Okay, so up to this value of force, object will not move. It will be, the friction on this object will be static in nature. If force exceeds this 11.76, object will move, and the nature of the friction will be kinetic friction. So kinetic friction will be mu k into mg, and that is equals to zero point 0.4 into 2 into 9.8, and that is equals to 7.84 Newton, right? Now, when F is equals to 12 Newton, 12 Newton is greater than limiting friction. So, object will move and the nature of the friction will be kinetic, and that is equal to 7.84. So, this statement is correct. When force is 10 Newton, friction force on the block will be 10 Newton. Yes, because 10 Newton is less than the limiting friction. So, nature of the friction will be static, and because of that, applied force is equals to static friction. So, again, this statement is correct. When F is equals to 7.84 Newton, again, nature of the friction should be static, and the frictional force equal to applied force in this case. So, it will be 7.84 Newton. But the option, it is given 0. So this statement is wrong. So only 1 and 2 are correct. Next is question number 50. A chain lies on a rough horizontal table, right, like this. It starts sliding when 1/4 of its length hangs over the edge of the table. The coefficient of static friction between the chain and the surface of the table is. So basically this is L by 4 length, and this is 3L by 4 length, right? And it is balanced by the weight of this L by 4 length, right? And this friction will try to pull this chain in the backward direction. Mg will try to pull this chain in the downward direction, right? So basically, friction force over here, mass of this 3L by 4 length will be 3m by 4, and into G will be downward force, normal reaction will be upward. So friction force on this horizontal portion will be mu 3 by 4 mg, mu mg, right? And it is balanced by the weight of this much chain, that is equals to m by 4 g. So this will cancel this. So mu will be 1 by 3, and that is option